temperature man. Let's say, kuha lang saan siya siguro. Max load. Diyan o. Okay, showing manito ang paano natay. Out of 1,500 customers, we have only conducted load survey sa 25 customers, individual households. So for us to generate or to approximate the rest of the connected loads sa tuwang feeder is you need to conduct a curve fitting of these parameters para ma-estimate na to ang maximum curve niya. So in that way, siya i-copy. So kini siya, kung siya i-plot, no? Kabalo mo gamit og kuan curve fitting, no? Kailan mo curve fitting. So insert, then scatter plot. So these are the load survey you have conducted. So individually na siya kung pila yang kilowatt hour na siya equivalent niya nga maximum load. So since limited naman ang atong load survey nga conduct, we need to generalize along the feeder pila yang equation. So mag-insert lang ka dara og trend line. And then let's say more options. So if you can see, line ring na nag-approximate, ang tawagan niya curve fitting. This line generalize this plotted data. So meaning to say, kining line, pwede na siya mo describe sa the rest of the load connected loads sa tuwang feeder. So ato lang makita din yung equation, unsa din na siya nga equation. So kung ato i-click display, so this is the approximate equation sa tuwang curve fit. Which describes the rest of the maximum load sa tuwang feeder. Nagets? So meaning to say, kung kini nga nakay equation like this, x nimo is kilowatt hour, with the information of the kilowatt hour, butang lang nimo dara, ma-estimate nimo maximum demand nimo. So let's say for example si number 26 na connected load, na siya around 200 na kilowatt hour. So, ang iyang estimate na maximum load is 0.0873 times the kilowatt hour demand plus 1.1227. So, it's around 18 watts ang iyang maximum load kada in the span of, let's say, in a month, no? If you have about 120 nga kilowatt hour, so the same equation ang follow. So meaning to say, tanan na dahil ma-generate, maka-come up na tao kilowatt, maximum kilowatt kada individual households. Okay, ganun importante na siya. So that once maibawa na to ang iyang relationship of the kilowatt hour to the maximum kilowatts, then we can plot this one and we can estimate the equation and we can generate the diversity factor table of the rest of the connected loads sa tuwang feeder. Okay? Okay, let's have an example. You have a single phase lateral provide service to 3 distribution transformer. You have T1, T2, and T3. Assuming nag-conduct og load survey. Pero ang load survey, out of the load survey, kining customer 1 to 18, wala sila kakuha og kanang exact value sa iyang kilowatt demand. But we have given with the equation estimate with the 0.2 plus 0.008 times sa iyang kilowatt hour. Assuming kabalo ta sa kilowatt hour sa tuwang customers, then we can estimate sa tuwang kilowatt maximum demand. Diba? For example, kung ang si customer 1, which is connected kini, naa siya energy of, or sa iyang bill, naa siya 1,523 kWh consumption. Using the equation, we can estimate siyang maximum kilowatts, which is 0.2 plus 0.08 times 1523, we have 12.4 kilowatts. Nagets? Wala.
Ang sawan na sir?
Ang watts niya. Importante mo ng watts, later on makita na doon saan yun siya yung relevance. So kung kada kilowatt hour, na siya equivalent mga kilowatts. Yun sa pag-derive, again, atong equation. Balik aning equation. Okay? So, pakita lang ako dali sa customer 1. But customer 2 will also follow, no? Kung nakay 1,645, i-input na rin mo siya dito, ang yung kilowatts is 0.2 plus 0.008 times 1645. Okay? And then, that would lead to your 13.4 na value. Okay? So, that's how we derive aning tanan connected load. So, 18 customers, we have around 18 ODCA values. So, with this information, we can now construct or determine sa iyang diversified demand kada DTs. Ang atong pangitaon ng load kada transformer nga loading. Eh kung imo na to kada individual load i-simulate or ato i-analyze ang kada connected loads, mas madako ang imong system. Then ang separation between transformer to your load, wala pa kay information kung pilay distance anang iya. Pero kung DT atong tanawon, ilang na to ang mga loads sa to ang transformer, then the analysis would be, I think, mas easier na siya. So let's say for example, you have a 15-minute night coincident kilowatt demand, and using the diversity factor table, you can determine the maximum demand. No? Let's say for example, sa transformer 1, pila po ang kilowatt maximum non-coincident? Maximum non-coincident. So it's simply summation of the maximum demand for an individual customer. You have 12.4
plus 13.4.
13.4,
16.1, 12.9, 11.9, 30.
how much is this? $66.7 kilowatts. How about transformer 2? Kung wala kami karon, manawag ko ha.
0.1 plus
Patindog daw, di cancer.
12.9 plus 13.8 plus 4.8 plus 16.3
81.6. Okay. And transformer 3. Ako na lang ang shortcut, pilay value. Kapit na ako ma-familiarize niyo pang lido. So, lido lang din. 117. So, kilowatts. So, that's how you determine the non-coincident. After ma-determine na itong non-coincident, unsa na ito pagkuha sa iyang individual or the transformer maximum diversified demand.
Kasi bintin mo.
Per transformer ha. So we all know that the diversity factor is equivalent to your kilowatt non-coincident divided by kilowatt maximum, right? So assuming na nata information na ning diversity factor katong nakaproduce na table, So I think we can utilize that one. So therefore, ang pag-calculate sa maximum diversified demand is, or the maximum diversified demand lagi, diversity factor multiplied by kilowatt of non-coincident. So for example, transformer 1, pila ka ito ang diversity factor? Diversity factor. We have 5 connected loads. So mo refer ka dito sa tuwang table. Kung natay 5 ka connected loads, ang diversity factor is 2.2. So ang factor is 2.2 times 66.7. Pilay value?
146.74.
Ha?
146.74.
146 kilowatts. So this is for transformer 1. Transformer 2.
179.62.
Pilay diversity factor? Pilay connected load ni Tito ganiya?
5.
2, 3.
5 ano?
Anong?
Isa ng isa, 2, 3, 4, 5 ano? No, no.
So,
So pilay diversity factor?
2.30.
2.3. So you have 2.3.
187.68.
81.6. We have 87.
0.68.
68.
Yes, sir.
So this is for T2.
Yes, sir.
And the last T3.
282. Marag 6 yata ito ba?
May connected customer.
7.
You have 7, no?
Grabe ka guys.
7.
1, 2, 3, 4, 5, 6, 7 din.
7 nga.
2.4.
So the diversity factor is 2.4.
195.84. Ha?
117.
222.
Di, 117
Ah,
nga.
117 man din na.
So,
So that's our kining nga mga maximum diversified demand kada transformer mo na tong equivalent nga transformer loading sa load allocation. In terms of planning or analysis sa any transmission or distribution, no, we always looking at the critical level niya. Kung saan maximum level sa loading, or we have a factor of the allocation factor or demand factor, that would be the good assumption sa tuwang maximum scenario. No? After this, makuha na din nato ang pila ato ang loading condition sa katong mga transformer, assuming nga natay
50.
rating sa atong transformer. So, assuming power put is we have a power factor of 0.9. So how do we derive the KVA equivalent loading sa atong transformer? This can be derived
Divide.
by power factor times
di.
4 kilowatt max 1 divided by power factor. Okay? This is the formula. So if you have 146.74 divided by 0.9, pila itong KVA?
16.
163.04.
63.04.
Ay, dili siya times, no?
Divide.
Kilowatt is kilowatt nan divide sa DF. Dili siya times. So, baliktad, dili siya.
Times nga na sa divide.
Baliktad niya.
Ay, sayop din na.
Times
Dili. I-divide ni mo ang kuan.
So, divide din siya.
Over
66.7 divide 2.2. 81.6 divided by 2.3. Then 117.5 divide 2.4. Pilang 1? 30.32.
Yes, sir.
Ang 2. Pila? 35.28. Number 3, 117 divided 2.4.
48.96.
Ha?
48.96.
These are all kilowatts, okay? Then after that, sa kilowatts, i-convert na to into KVA.
Ha?
So 30.32 divide 0.9, pila tong KVA number 1?
Ano ka, ano? 32.30.
33.69. This is in terms of KVA na. KVA number 2.
Ano, 35.40.
So, still,
35?
yung copy lang
40.
si kilowatts, divided ka sa assumed na power factor kada loading, no?
39.42.
39.42. This is KVA.
Yes, sir.
Then, KVA number 3. 48.96.
54.18.
44?
54.18.
4 man, 96 man.
Eh?
54.4.
96 minutang.
Oh. Sorry.
Okay, these are your loading, no? Loading condition.
Love you po na ka.
Hindi
And
na.
if you compare it sa yung ratings,
Sibin mo.
si Transformer 1,
Oo. Tama na.
nasa rating at 25 kVA, pero ang yung loading, maximum loading is mabot na 33.69. Okay? If you ratio that one, it's around 135% nasa yung rating.
Sobra na.
Dako kayo. Si Transformer 2, 37.5, 39.42 kVA ang rating. So I think it's less than 105% or 10%. And si Transformer 3, from 50 kVA, nasa 54, so mga 108%. Ang pinaka-critical nila, si Transformer 1 because it's around 135% nasa rating.
Okay.
Again, we cannot draw conclusion here na kailangan na replace si T1 because wala pa natin nakita yung duration curve. So, but this one, indication na ni siya nga we need to further investigate sa Transformer 1 kung sustain ba ang kining loading na 135% in actual. So that's how you conduct na dayon ng Transformer load management. So kung dili gani siya, kung kini siya overestimate lang siya, so that's fine. Pero kung indicate kuan na siya, nag-sustain siya of further 5% or 10% sa imong daily load curve or duration, then that's the time we can propose for replacement. Okay? Any questions so far? Okay. So, from the transformer, we have the loadings. Maka-create na ta sa itong load flow or sa itong calculations. So we need to have the segment na loading po nato or atong transmission line na or distribution lines na loading. So in this case, this is the conventional method, no? Sa mo ni siya ang ginagamit sa mga wala pang advent sa sa SCADA or the microwave. So aside sa transformer loading, we need to take a look at sa iyang segments. Kay lateral connections man nato ang transmission, no? Or distribution system. Naka 3-phase dra, naka-lateral na ang mga DTs. So in between sa mga DTs, dahil siya og loading. Kini nga segment nag-loading compared ani. So mas heavy ang imong loading dire compared sa ani, assuming na dire itong supply. Okay, so we need to segment the load connection sa tuwang DTs. So we have N1 to N2, one segment, N2 to N3, another segment, N3 to N4, another segment. So if you now see N3 to N4, ang load nga or ang current na mo flow diri sa tuwang segment is only the loading sa tuwang T3. So I think
Lapas ba
the
sa report
condition
na-
sa tuwang
TBU?
segment third is definitely parehas lang sa transformer 3. But for the segment number 2, kailangan to, ang yung loading ng mga gidere, transformer 2 si transformer 3. No? Kaya assuming diretso supply, so diretso kita, padulong pa dito. So na-demand rin, muagig siya direct. So pinaka-heavy loaded, kinidil sa to ang near sa to ang
N1 again.
feeder. Feeder
Ito lang
head.
mga ganun.
So we need to segment na, so N1 to N2, assuming pa siya, transformer, so we have around 18 total number of customers connected, then we need to get the kilowatt non-coincident niya, which is summation of all maximum demand of customers. So pila yung summation na nila? We have 13.4 plus 66.7 plus 117.5.
N1 to N2 din.
Apel pang 13, sir? 13.4?
Yeah, 66, 81 of 117 din.
Ito 65.8.
265.
0.8 kilowatt.
Okay, sa N2 to N3, we have around kilowatts of 42 at 3, no? 81 plus 117.5. Pila?
199.1.
And sa last na segment, N3 to N4 is just the same, no?
17.5.
117.5. Now we need to get the maximum diversified demand niya. So how do we get kilowatt maximum direct? We have kilowatt non-coincident divided by sa iyang diversity factor. So from N1 to N2, since naman tayo 18 number of customers connected, so i-refer ko nato sa tong table. Kung 18 na gani,
Sabot mo.
Kulang man, sir.
we have this one.
Oh.
2.86. So 265.8 divide 2.86. So how much is your kilowatt max?
92.94.
100
92 sir.
kilowatts. How about this one? We have 199.1 divided by how many connected customers ato? 18 minus 5 na tayo 13. So 2.74. How much is your maximum kilowatt? Ah?
43.47.
43.47?
Ang number 1 sir, 92.1.
72 man.
92 lang eh.
72 man na, sir.
72 man na sir.
Kanang N2 to N3. N2 to N3.
2.3.
Dire sir.
But 165 divided by 2.86.
Yes, sir.
Sakto na to, sir.
Pila man?
Ang kanang ubos, sir.
92, 92 is 99. This one is
72.66.
Wala ni gamay mo sir.
2.74.
66.
13.
and the last one is just the same with 3, ha?
Oh.
We have 48.96
96.
kilowatts. Okay?
6 plus 7.
Huh?
6 plus 7, 13. Tapos sa diversity factor, 13 ang piliyon na.
So, ito pa dayon na siya.
Ay,
Check na dayon siya.
Bila.
Check, purpose din na dayon.
Into
Makadetermine na to ang loading na to kada segment. So if you have the N1, you have the load condition here, N2. You have the loading of T1, N3, N4, N4. This one is 42. This one is 43. So, butanan mo yung parameters dira, pilang demand dire sa T1, T2, T3, and also the segments. But aside from that, nakoy natong transformer load equivalent. Di na sa tamo jump pa na later balikan na nato siya. But this is the load allocation na, so these are important na parameters. Mo ni siya mo reflect dapat dire
Sa box.
dira. And then sa mga loadings pod, kini nga loading kilowatt lang.
Dito. Sa T1. T1. To.
Okay? Later we'll come back to that one. Before we go to that voltage drop, let's discuss first the other types of load allocation calculations. Napay-update sa BFP ang busy ang BFP karon kay nagkuhan pa mangud sila na
Kanina yung bago yun.
Ano naman?
Muragas lug.
ha? Hindi mo na BFP.
Wala sa tubig daw.
Wala mo yung master.
Busy.
Ma-update ka, taon-taon siguro si ma'am. Ang nag-coordinate na. Sir, nasa sa date? Lagi pa ako.